Hello guys, you okay? Good, good. So I want to summarize what I did yesterday, and then I will talk about some more stuff. So let me begin by summarizing what we did yesterday. Okay, so yesterday I began by doing a second example on copulas. I did example 2 on copulas, right? So this was the second example I did yesterday, and then I talked about the two most popular copulas, right? The first one is the Gaussian copula, also known as the normal copula, which is given by this formula here, right? Okay, this is the formula for the Gaussian copula. Okay, but then unfortunately the Gaussian copula is not a good model for the financial data because it doesn't fit the financial data very well. Okay. However, before 2008, big companies, including the Wall Street, have been using the Gaussian copula to model portfolios or portfolio of losses. So, I mean, that may be one reason why the financial crisis was in 2008 was so bad. Okay, and then I gave you this article. I gave a copy of the article that the formula that killed the Wall Street, which is the formula that I just wrote down. Okay. Then I talked about the T copula. I'm trying to find where it is. I may not have it here. I don't know where it is. Where is the T copula? Where is the T copula? Oh, here it is. Okay, the T copula is here. So this is the T copula. The formula for that is this one, where this is equal to this and this is equal to this. And the T copula is being increasingly used in the financial sector because it provides good fit to financial data. Okay, so this is the T copula that I talked about yesterday, and that was the end of this chapter on copulas. Then I moved to a new chapter, and the name of the new chapter is the Bivariate extreme value theory. So here we look at extremes of not just one variable but two variables. Okay, I gave you 3 examples where extremes of 2 variables are of interest. The first example is in flooding, where extremes of rainfall and wind speed are of interest. Now this is the first example I talked about yesterday. The second example I talked about yesterday was droughts. Okay, when you have droughts, again you're interested in the extremes of rainfall, because so little rainfall, and temperature, right? And the third example I looked at was this one here, is forest fires. When you have forest fires, you're interested in the extremes of temperature and wind speed, right? High temperature and high wind speed can cause forest fires. I brought some pictures today just to show you. I didn't have these pictures with me yesterday. So like here, this is forest fire. No, this is a forest fire, and it's caused by extreme values of temperature and wind speed, right? Okay, this is forest fire. And this is tornado. Tornado is very common in the United States, and it's caused by extreme values of humidity and wind speed. Okay, that they cause tornadoes. And there's some more pictures. Hurricanes. Hurricanes, again common in the United States, are caused by extreme values of sea temperature, rainfall, and wind speed. Right. So here you are interested in extreme values of 3 variables, right? And then droughts. Of course, droughts are caused by extreme values of rainfall and temperature, right? There's two more pictures. This is El Nino. You may have heard about this. El Nino is a phenomenon that is caused by extreme values of sea temperature and air pressure. So here you're interested in 2 variables, extremes of 2 variables. And the last one is floods, of course, which I talked about yesterday, caused by extreme values of rainfall and wind speed, right? So these are some examples I wanted to show you yesterday, but I hadn't printed them out. Okay. All right. Then I talked about how to define a bivariate extreme value, right? And I told you that there is no one way of defining a bivariate extreme value, right? But the most common way to define a bivariate extreme value is through this method here. So you have a vector of 2 values. The first one is the maximum of the x's. The second one is the maximum of the y's, right? Okay. Okay, that's talked about yesterday. And the next thing I gave you an example. I gave you an example where the bivariate extreme value is not an actual observation, right? In this example, the bivariate extreme value is 8,9, but 8,9 is not a data value. Okay, so that's one weakness of the bivariate of the definition. But nevertheless, that's the most accepted definition of bivariate extreme values. This is the univariate case, which you all know. The next, I wanted to find the joint CDF of this. Wanted to find the joint CDF just in parallel with this, the univariate case. Just to be in parallel with the univariate case, I wanted to find the joint CDF of this. And it turned out, after some calculations, the joint CDF becomes equal to this. This is the joint CDF, right? Okay. And then I asked the question, what is the limit of the joint CDF? Sorry guys, what is the limit of the joint CDF as n approaches infinity, right? And the result was rather surprising, because unlike in the univariate case, where in the univariate case the limit can only be one of 3 cases, right, as you know, if it exists. But in the bivariate case, if the limit exists, it can take uncountably infinite different forms, right? So that's what this says, right? If the limit for g exists, it can take uncountably infinite different forms. And then I showed you how to, I described a procedure on how to find the g if it actually exists. How to find the g if it exists, right? Okay. All right. And this is a 4-step procedure. The first step is to find the marginal CDFs. The second step is to find the max domains of the marginal CDFs. And the third step is to choose the A and B and C and Dn, right? Uh, and the fourth and the final step is to find the limit of this as n approaches infinity. Right, then I started doing an example, and this is an example I wanted you to do. Did you guys have time to complete this or not? So this is an example I gave at the end of the class yesterday. You remember or not? Yeah? Did you have time to complete or not? I asked you to think about it. Alright, so the first step is to find the marginal CDS, which is this one and this one. We have found the two. Now what is the second step? The second step is to determine the max domain of attraction, right? Now, what is the first? Okay, let's take f of x. First we need to find the upper end point, right? So we set okay. Can you see this, guys, or no? I'm trying to see if my writing.
Yeah.
Huh? Oh, is it? You can't see it? Now it's okay. You can see it now? Okay. Okay. So this implies that this implies that e of minus x is 0, and this implies that minus x is equal to minus infinity. So x is equal to plus infinity. So in other words, w or omega of f of x is equal to plus infinity. Okay, is that right? I mean, this is the way, I'm sure. So this is the way to find the, I'm sure all of you guys know, this is the way to find the omega of f x, right? The next step, okay, let's check condition 1. Do you guys remember condition 1? Right, this is condition 1. Okay. So we want to take the limit of this as t goes to infinity. Alright, so this is going to be the limit as t goes to infinity of of this. Okay. Now, how would you simplify? Oh shit! Sorry. Oh. How would you simplify this? Huh? How do you simplify this, guys? I'm sure. Huh? Because you can see that. Where's my pen? you can see that this guy here, where does it go? As t goes to infinity, this goes to 0. And so is this one. This also goes to 0. Alright? So using one of the results I gave you, this can be written as limit Alright, you know the result I have used, right? I mean, it's one of the results I gave you a long time ago, some time ago. Alright, so you can write this as this. So the 1 and the 1 cancels, the 1 and the 1 cancels, right? So you have this, okay? Then, so you have this is equal to the limit as t goes to infinity of e of minus t minus x gamma x t divided by e of minus t. Are you guys okay or not? But did you? Are you guys okay with that? Okay. Do you have any questions? Yes. No. Yes. Okay. All right. So this becomes the limit as t goes to infinity of e of minus x gamma xt, and this is equal to e of minus x if gamma xt is equal to 1, right? So hence fx belongs to the right, okay, hence fx belongs to the control max domain of attraction. Similarly, I'm not going to repeat the calculations, I'm sure you can do it. Similarly, Fi also belongs to the Gumbel max domain of attraction with right. Are you guys okay with me? I mean, if you have questions, feel free to ask me. Are you guys okay? You okay? Yeah. Okay. Good. All right. So we have completed step 2. Remember, step 2 was to find the max domain of attraction of the two marginals fx and fy, and we have done that. And the next step The next step is to find A and B and C and D and, right? So let me call this step number 3. All right. Now remember the formula for AN. If both belong to the Gamble domain of attraction, the formula for AN is as follows. Right, and this will be equal to 1. Right, because gamma x, it doesn't matter what the argument is, always 1. So this is equal to 1. Now to find Bn, we need to find the inverse function of this. So what I'm going to do is the following. So to find Bn, I need to set fx of x equal to 1 minus 1 over n and solve for x. Right? So this implies that okay. So this implies right, which is equal to 1 divided by n minus 1. Okay, so minus x is equal to minus log of n minus 1. So x, hello guys, are you following me? So x is equal to log of n minus 1. So in other words, what I have shown is that the inverse function of x is this. Okay, so in other words, Bn is equal to log of n minus 1. Right, similarly, I'm not going to repeat this one more time. Similarly, you can show that Cn is equal to 1 and Dn is equal to log of n minus 1. Are you guys with me so far? I mean, do you see how I have determined A and Bn, Cn and Dn? Yeah, any questions so far? You guys clear? Yeah, okay. Alright, so we are done with step number 3. Now the last step is step number 4. Is to find the limit. So we are at the very last step. Which is the limit we need to find the limit of this as n approaches infinity, right? Now we know the formula for we know the formula for f, which is given here. This is the formula for f. So can you see this, guys? This is the formula for f. So all we need to do in place of x we need to sub this term, and in place of y we need to sub this term. Alright, so that's what I'm going to do now. So this is going to be, just bear with me because I'm really trying to, because I can't see this, I'm really trying to write something without seeing it. I hope. Alright, this is what you get. Do you guys see where I got this from? Hello guys. This is the formula for the CDF that we were given in the example, right? So that's how I got this. So this becomes now we know that n is equal to 1, right? So this will be EF minus x, and we know that Bn is log of n minus 1, right? And plus okay, and then okay, like this. So do you see what I've done so far? Any questions on what just try to understand each. Try to understand every step I'm doing. If you don't, please feel free to ask questions. Okay. All right. Now the minus. You can take the e of minus log of n minus 1. What would that be? Take e of minus log n minus 1, it will become okay, and these two make up 2 squares, so it would be 1 minus a okay. Do you see? Do you guys see how I got from this line to this line? It's just simply using the fact that EF minus log n minus 1 is 1 over n minus 1. And the same thing here, EF minus log n minus 1 is 1 divided by n minus 1. And here you have two terms, right? So minus log n minus 1 minus log n minus 1, which is 2 times log n minus 1. So when you take the e of that, it becomes n minus 1 squared. Right? Okay, guys? All right. Okay, the next step Okay. Okay. What I have done so far is to, okay, there's a square here. This should be a square. Okay. I have introduced a n in the denominator all the way, right? Okay. Now let me put this here. Hopefully you can see this, right? In the next step, I'm going to do the following. In the next step, I'm going to take the 1 over n outside, okay, and then inside you will have the following terms. I know it kind of looks complicated, but it's really not. Okay, to the power n. Okay, now let me call this here. Let me call this thing here. Right, let me call this equal to z or z, right? So what you have is the following. You have the limit as n goes to infinity of 1 plus z divided by n to the power n, right? Now I think I mentioned this before. See, I call everything inside the circle equal to z, right? So this is what you have. Now what's the limit of this? I'm sure you know this. This is e to the z, yeah? So the limit of this is equal to the limit e to the z. Now, but z also depends on m, so we need to put that back. E of, okay, okay, let's okay, the z is, as I said, is this term here, which is e of minus x times n minus 1 and then okay, this is what you have. Alright, now let me ask you, what is the limit of this as n goes to infinity? This goes to 1, and this goes to 1, and this goes to 0. Alright, so the limit is the following. That is e exponential of did I miss a negative sign somewhere? I think it's something. Did I miss a negative sign? Why is it? What? Come on, guys. You should have told me. Is it here? Seems. What is F? Sorry. What is F actually? F is what? Power minus 1. Okay, I know why. I know what happened. Yeah, so it should have been minus n here. Minus n. Sorry, I apologize for this. Minus n all the way. The power should be to the power minus n. Right? So this should be minus n. This should be minus n. So the limit of this is e of minus z. Right? So there should be a negative sign multiplying all these terms. So let me use my tip backs I bought for this. Yeah, all this should be, excuse me, so this should be negative. There should be a minus sign here, and a minus sign here, right? So the answer should be the following. It should be minus e of minus x minus e of minus y. Alright, so this is the final. See, it took a while. I know it has taken a while to do this question, but in the exam you will. I mean, you should, once you do a few examples like this, you will get used to it. So in the exam you have to do this question in about 30 minutes or so, right? So you have to really practice this kind of questions. You know what I'm saying? All right. So the limit. So the answer to the question. So hence, g of x comma y is equal to this. Okay, it's equal to this, right? That's it. So that completes example 1. Right? I would like to do another example. But okay, let me do one more example if I have time. I mean today. So example 2. Any questions on? Okay, before I do that example, any questions on this example you guys have? Are you sure? So example 2. Example 2 is the following, right? Suppose, if you have questions, feel free to ask me, guys. I mean, I'm happy to help you all the time. Okay, so here f bar, not f. You know what f bar is, right? F bar is the joint survival function. So the question is to find g if it exists. Okay. So the first step, as you know, is to find the marginals. So you put, to find the marginal for x, you put y equal to 0. Okay, so this would be e of minus x. So this implies that f bar, not f bar, the marginal CDF of x is this, right? To find the marginal for y, you put x equal to 0. So this will become e of minus y. Sorry, not f bar. Why am I doing this? Okay, so this implies that the marginal CDF of y is this. So both margins are exponentially distributed, right? This is exponentially distributed, and so is this one. So step two is to find the max domain of attraction. I'm sure we did this example a long time ago. Do you guys remember this? Do you guys remember this and this? We did it a long time ago as an example. Do you remember the max domain for the two? You don't? Come on, guys. You don't remember? Oh wow. They both, I don't have the time to do it, but you can check. Both, come on guys. I thought you had better memory than I do. Okay. Both, I think we did this example a long time ago, and if you look at the notes, you will see that both belong to the Gumbel max domain with gamma x equal to 1 and gamma y is also equal to 1. Okay. All right. And next, step 3. Step 3, you guys okay? We know that an is gamma x of f and this must be equal to 1, right? Because gamma x is 1 for any argument, so this is clearly equal to 1. Bn is this term, so we need to set the CDF to find the fx inverse of 1 minus 1 over n. We set the CDF of x equal to 1 minus 1 over n. So this implies that 1 minus equal to this. Okay. So this implies that e of minus x is equal to 1 over n, and this implies that x is equal to log of n. So this implies that fx inverse at 1 minus 1 over n, can you see my writing, guys? Yeah, is equal to log of n. Okay, So that implies that your bn is equal to log of n, right? So similarly your Cn is equal to 1 and your Dn is equal to log of n. Okay. Alright guys. So we have determined An, Bn, Cn and Dn. Alright, so the last step, which is step number 4, is to find the limit. Of the CDF, right? Step number 4, we want to find the limit of f an x plus bn cn y plus dn to the power n. Okay, so this is gonna be, come on, what did I write here? Limit as n approaches infinity. Okay, so this is the limit as n approaches infinity. Alright, now let me ask you guys, a simple question. What is this joint CDF? What you are given here, guys, is the joint survival function. So how do you determine the, I think I told you this before a long time ago. How do you determine the joint CDF from the joint survival function? There's a formula I gave you. You remember? This is the joint survival function, right? How do you determine the joint CDF? You remember the formula? Come on, guys. I gave it to you a long time ago. Anyway, if you don't remember, I would just write it down. But please look at what I gave you in the notes. Plus this guy here, which is alright, is the whole thing raised to the power n. Yeah, this is what you have. Okay, now we know the values for the an and the bn and the cn and the dn. An is 1, cn is 1, bn is log n. So you sub in all the values, this is what you get. Yeah, and then over here you will get plus yeah, then the whole thing power raised to n. Alright, I know I'm being a little clumsy, but I hope you can read my writing. I hope you can read my writing here. Okay, I'm sorry for not being. Okay, so this will become the limit and you should pull out the log n term, which is common. You will get the following. You will get plus e minus log n, then in brackets you will have the whole thing power n. Okay, now e minus log n, as I said before, is 1 over n. So you can combine, you can write these as limit of 1 you can write this as limit of 1 minus 1 over n, and inside it you will have the following terms: e of minus x plus e of minus y, and you have just a minute, you have it's gonna be tricky because n, okay, you have plus okay, you're gonna have plus, not plus, I mean minus, oh, well, you're gonna have a minus n